In this video segment, we'll take a look at solution stoichiometry. Now, this shouldn't be horribly new to us. All we're going to do is use the molarity, which is the ratio of moles of solute to liters of solution, to convert back and forth between a volume of a solution and moles, and likewise going from moles to volume as well. So we'll take a look at how that works out. The reaction we're going to take a look at is an oxidation-reduction reaction between iron 2+ ion and permanganate ion. This happens in an acidic environment, so you notice the 8H+ as one of the reactants. And then we're going to look at this as a titration. So it'll look a lot like the acid-base titration that we've done in class, or we will be doing in class. So we have our burette filled with the permanganate ion. The positive ion that's part of that spectator ion is potassium permanganate. And so what we're going to do is we're going to go ahead and add the permanganate to the iron solution, which is in the bottom. Now notice the iron solution is starting out at 25 milliliters, and we have our permanganate solution concentration over on the side, 0.1773 molar. So I'm going to add some here, and again at the beginning we can do a decent amount until we start to notice that the solution is changing color, and of course there we have gone too far. So as a simulation we can just repeat this. So similar again, a little bit more trouble if you do it in the lab. You've got to redo all your solutions here. We just push a button. So we're going to start again, and again we're going to add larger quantities until we start to see a change in color. So there you can see that the color is changing. So now we're going to go dropwise. And again, ideally we would get to where one drop would change the solution to an all purple color, indicating that we've reached the end point. Kind of a case to note here, because the color is due to the permanganate, in this case the end point actually would be the equivalence point, because we're not using an indicator that's pH sensitive, but one that actually is involved in the stoichiometry of the reaction. And I think I would rather have the burette stopcock to turn rather than pushing the button on the board here. There we go. So we've now changed color. So let's take note of some of these, and then we'll go back to our equation. So notice that we've got 27.1 milliliters of the permanganate that's added. So we subtracted the, obviously this burette's not done real well, but it's not like the ones in class. But so we've added 27.1 milliliters of the permanganate. The concentration of that is 0.1773, and we started off with a volume of 25 milliliters of the Fe2+. So let's go back to our balanced equation, and let's fill this information in. So the iron, we had 25 milliliters, and we wanted to figure out the molarity of that. We have a molarity of 0.1773 molar for the permanganate, and we've added 27.1 milliliters of that. So to figure out the molarity of the iron, we need to get the number of moles of that. So we're going to start with our mole, the volume of the permanganate, and we're going to go from this volume to moles of permanganate to moles of iron, and then we'll plug that into the molarity formula for the iron. So 27.1 milliliters of the permanganate solution We know from the molarity that every 1,000 milliliters is 0.1773 moles of the permanganate. So we could stop there and figure out how many moles of permanganate we added. However, we're going to continue on and figure out the moles of the actual iron that it must have reacted with. So we know that for every 1 mole of the permanganate, we must have reacted 5 moles of the iron, iron to iron. So again, we just use the coefficients in the balanced equation. And if we do the math there, we end up with 0.0240 moles of the Fe2 plus that we started with. Molarity, a different color, is going to be the moles of Fe2 plus divided by the liters of solution. So we just calculated 0.240 moles of the Fe2 plus divided by 0.025 liters, which gives us a molarity of 0.961 molar. So that would be the molarity of our iron solution. We go back to our page. We plug that into the box here, and we find out that we actually did this correctly. So this is something you can do on your own. So just go to the Smartboard page. You can click on this. There's other reactions that you can do. So you can use one with potassium dichromate and tin, and one with iodine and thiosulfate. So different reactions, different types of calculations, but they'd be good practice. Another thing we could do potentially with this reaction, let's give ourselves a little bit more space, but we could determine the grams of water produced, perhaps. That might be a question that we would be asked to do, is how many grams of water were produced in this process. And again, all we're going to do is we're going to use the volume of our permanganate solution that we started with in the titration, or that we use in titration. We're going to figure out how many moles that was. We'll use our balanced equation then to figure out how many moles of water would be produced. So for every 1 mole of the permanganate that is reacted, we're going to produce 4 moles of water. And every mole of water, of course, we look at our periodic table, would be 18 grams of water. And when we do our math here, we should probably cancel out the units just to make sure everything works out. So moles of permanganate, moles of water, grams of water left over. And if we do our math, we get 0.346 grams of water as being the amount produced. So you can see then that you're using the volume of one of the reactants to figure out how many moles using the molarity, and then going to grams of water. So this is going to be another one where we just need to kind of dust off our stoichiometry skills, but we shouldn't have too many difficulties with this.